Hello students, today we are going to study about the effect of change of pressure, on the different states of matter. We are studying this chapter, matter in our surrounding. Topic which we are going to study today is again what? Effect of change of pressure, on different states of matter. But before studying that, I want to say to you about the units of pressure. So common unit of pressure is what? This atmospheric pressure and bar. But the SI unit of pressure is Pascal. How they are related? 1 atmospheric pressure is equal to 1.01 into 10 to the power 5 Pascal. Regarding bar, 1 bar is equal to 1 into 10 to the power 5 Pascal, and when 1 bar is equal to 1.01 atmospheric pressure. At the sea level, the atmospheric pressure is what? 1. And as we go higher, you'll see that at higher altitudes, what atmospheric pressure decreases. Now, here this is all about the units of pressure. Now we are going to study effect of change of pressure in detail. So how does this pressure affect the change in the state? So for this we will be performing an experiment. In the experiment we are taking 3 cylinders. In one we are keeping what? Solid, another we are keeping what? Liquid, and in the third one we are keeping what? Gas. And what we are doing? We are applying pressure through the piston, and we are seeing that what happens in case of the solid, the particles are closely packed, isn't it? So when we will be applying pressure, what will happen? Will it be compressed and be becoming more small in nature? We can see in the experiment that yes, we can't do that, because here the particles are too closely packed. The space between the particles are not present. Now here we are seeing, in case of the liquid, the space is there comparatively more than solid. We are seeing when we are applying pressure through the piston, what is happening? It is being compressed, but only to a certain extent. But with the gases, you are seeing what? When we are compressing it with the piston, what happens? It is getting easily compressed. And if in case of solid, we will see that if it is being compressed, it will come closer. Now the particles are behaving like the particles of the solid, so this liquid state will be changed into solid state. But when we are compressing the gases, what will happen? First the gases will be compressed to the solid state. First the gases will be compressed to the liquid state, and then if we go on compressing to a very high extent, it can change into what? The solid form. So here we are seeing, according to the particles present in the solid, liquid and gases, according to the spaces present, the pressure that changes the state. In solid it is impossible, or nearly impossible I'll say. In liquid it gets compressed only to a certain extent, but in the gaseous state, if we are applying pressure, it is being compressed very easily, and the result converts into the liquid form. But here, one thing is to be remembered, that if we are applying the pressure, increasing the pressure, the temperature, here we have taken room temperature, we should not increase the temperature. If we increase the temperature, what will happen? The kinetic energy will increase, because when we are compressing, as the molecules are coming close to each other, it means what? Here the kinetic energy is being decreased. Now we have seen that in case of solid, liquid and gases, the effect of pressure, the volume of the solid doesn't decrease, even though if we are applying pressure, because of more intermolecular forces and less interparticle spaces. In liquid we have seen that the volume gets decreased only to a certain extent by applying pressure, isn't it? And this is because the space between the particles are a bit more than the solid and less than the gases. Intermolecular forces are also bit less than the case of the solid in case of liquid, but when we are seeing in case of gases, the volume gets decreased. Why? Because here tremendous amount of spaces between the particles, intermolecular forces are very, very less. So all these, if I sum up, we come to the transition between the three states of matter. We see how we have studied. Here we can see when a solid is changing into the liquid form. I said to you what it is known as fusion. And when a liquid is being changed to solid form, it is known as solidification. Now, when liquid is changed into gaseous form, it is known as vaporization. Okay? And when a gas changes into liquid, it is known as condensation. Okay? And when a gas changes into solid, it is known as deposition, and when a solid changes into gas, it is known as sublimation. Here all the words you are familiar to except this condensation and this deposition. So right now I am saying you about condensation. Here you are seeing what the gas, when it changes to liquid form, it is known as condensation. So how does this happen? Suppose if any water vapor comes in contact with a cool surface, what happens? As it comes in contact with the cool surface, it forms what? Water droplets. So here there is something, what happens when the gas comes in contact with the cool surface. I am saying if the gas is coming in contact with cool surface, the kinetic energy of the gas is more, but the surface is cool. As the result, what will happen? The kinetic energy of the gases will decrease. Its interparticle spaces will decrease, and as the result it will form water droplets, and hence the gas now has been converted into the liquid form, and this is known as condensation. Now come deposition. Okay, gas to solid form. See, I have said that gas, all the states are can interchange, isn't it? But here directly the gas is being changed into the solid form, and that is deposition. Here we can take the example of what? Solid carbon dioxide. If tremendous amount of pressure is applied on gaseous carbon dioxide, it changes into what? Solid form of carbon dioxide, and that is known as dry ice. That is known as dry ice, and this is an example of deposition. If tremendous amount of pressure is applied on this gas, it forms the solid, and naturally if we decrease the pressure to 1 atmospheric pressure, again this solid carbon dioxide changes into its gaseous form, and hence it can't wet anything, and so we say that this dry ice cannot wet anything like that of our common ice which we have of water. Now we are going to study what? The topic evaporation. You are all familiar with this word evaporation. Means what? Here the liquid is being changing into gaseous form, but how it is changing? It is changing at its boiling point or at its room temperature only. Okay, here there lies the criteria of explaining what evaporation and boiling. It does not need the boiling point. It can change at any temperature. So what is this evaporation? Evaporation of changing of a liquid into its vapor form at any temperature below its boiling point. Okay, so how, now I'm going to explain you how this evaporation takes place. Actually what happens, this evaporation takes place in liquid. Okay, you can see the figure here. You can see how the molecules are present in this liquid. All the molecules are having different energy. Okay, they are in motion, they have free space between it, so they are in motion, and they are having kinetic energy. All the molecules are having different kinetic energy. At the surface of the liquid you can see the kinetic energy is being more. Actually what is happening here at the surface, it can absorb the temperature from the surrounding, and as the result what happens after that, it's the surface molecules kinetic energy increases and it tries to escape in the atmosphere. Once it escapes in the atmosphere, naturally the other particles which are on the surface will again try to balance its energy, because now the energy has become less, because the surface molecules have taken energy from the surroundings as well as the rest of the liquid to change it into the vapor form. And as the result, what will happen here, now the rest of the liquid which is present will try to adjust its kinetic energy, and it will take again the energy from the surroundings, and its energy will become more, and it will try to escape in the atmosphere. And this is known as what? Evaporation. I said you that it is the change in the liquid form to the vapor form at any temperature below its boiling point. Okay, so now this is all about the explanation of evaporation. Now factors that are affecting evaporation. What are the factors which are affecting evaporation? Surface area of the liquid. How can we say that surface area of the liquid affects evaporation? Suppose the surface area is small and another surface area is more. I said that evaporation is a surface phenomenon. Naturally, if the surface area will be more, evaporation will be more. If the surface area is less, evaporation will be less. Now the nature of the liquid. Suppose if we are taking water and if we are taking alcohol, which will evaporate first? Alcohol, isn't it? So it depends upon the nature of the liquid, how it is. It will evaporate accordingly. Now temperature. If we increase the temperature, naturally evaporation will be faster because we are applying kinetic energy to it. And if we decrease the temperature, evaporation will become slow, because here what happens, we are not applying temperature, kinetic energy will not increase. Humidity in the air. Humidity means what? The presence of water vapor in the atmosphere. Here, humidity, if the water vapors are present in the atmosphere in large amount, naturally the water will not evaporate fast, because before only the saturation point is there in the atmosphere. Now wind speed. Have you seen when we wipe the floor with wet cloth and when we on the fan, we see that yes, it gets dried up faster. Why? Because there we had used the wind of the fan, the air of the fan, okay, to evaporate the water. So if wind speed is more, evaporation will be fast, and if wind speed is less, evaporation will be slow. Now, next is examples of cooling caused by evaporation. First, cooling, I will say you why does evaporation causes cooling. Okay, I said to you that evaporation is a surface phenomenon. It is taking the temperature from the atmosphere as well as the liquid present over there. So what happened if it is taking the temperature from the atmosphere and the liquid over there? Naturally, what will happen? The temperature will decrease of that area at least, because it is taking the energy and it is using that energy to convert it into what? The vapor form. Here the liquid form is converted into what? The vapor form, and so it is using that energy, and as the result that area will become cool in nature. And once this, I said you, the surface molecules have been evaporated, and again the next layer which is coming, in which now the kinetic energy is less, again we'll try to take the temperature from the surroundings, and it will try to increase its kinetic energy, and again it will try to escape in the surrounding, and as the result making that surrounding what? Cool in nature. So now I am going to explain you examples of cooling caused by evaporation. First is, we sprinkle water on the roof in summers. You all do, isn't it? Why do we do this? Why do we sprinkle water on the surface of the or why we sprinkle water on the roof in summers? Actually what happens here, the phenomenon of evaporation takes place. It takes the heat or the temperature from that area as well as from the atmosphere, and making that surrounding cool in nature. Now, water kept in earthen pots. Earthen pots have got small pores in it. So what happens? The water seeps into that pores, and as the result, it takes the temperature from the water inside the pot as well as the surrounding, and it escapes in the surrounding in the form of water vapor, leaving behind less kinetic energy in the earthen pot and giving it what? The cool nature. Now, wearing cotton clothes in summer. What happens in summers? We sweat, and if we sweat, naturally evaporation will take place. And if we are putting on synthetic clothes, it will not absorb the water, and as the result, atmosphere will not be in direct contact with that sweat, and evaporation becomes difficult. But what happens when we put on cotton clothes in summers? What happens in this? The cotton clothes absorbs the sweat, absorbs the water of the sweat, and as the result, what will happen here? The evaporation becomes easy, and as a result, it keeps the body cool. Now, we are able to sip hot tea or milk from the saucer. Hot tea, we can able to sip the hot tea or milk from the saucer rather than from a cup. Why? What happens? In the saucer, you can see the surface area is more, isn't it, from that of the cup. I said to you, if the surface area is more, evaporation will be more faster, more the evaporation, more the cooling, and as the result, to sip it from the saucer, it becomes easy rather than from the cup. This is all for today. Good day.